Let's see, there we go. All right, folks. Whoever wants to learn math from someone other than Jordan Peterson, be my guest. Let's see. If people can't be respectful, I'm going to have to limit the chat. Okay? Should be pretty straightforward, but there are many, many psychotic males on this app. And that's right. You realize 85% of my viewers, roughly, thus far have been men. Why? Pretty much every unhinged person that I would say has gone way too far in the comments has been a male. And yeah, so there's that. And also this strange demand for male supremacy and this sort of bargain that men get to have the authority over women, but only if women devote themselves individually and their life's purpose to some individual male. Don't get me started on how stupid that is as far as our end of the bargain. Men who won't go after men or blame men are not worth devoting your life's purpose to. Okay, that's all I'm going to say about that for now. Let's see. Today, folks, we're going to get really deep into some hard stuff. This is a Shams outline. If you've never, it's pretty sure it looks backwards to you or something, but like if you've never seen a Shams outline and you're trying to learn math, they have a book like this for pretty much every subject that you could want. Pre-calc, trigonometry. I don't want to compare these to Cliff's Notes because these are way better than Cliff's Notes for math than Cliff's Notes are for literature. I think Cliff's does other subjects too, but mostly I'm familiar with Cliff Notes about particular books, especially Shakespeare. I'm not saying don't use Cliff's Notes for Shakespeare, but I think what people expected to get out of Cliff's Notes back in my day, before we were looking for every freaking thing on the internet, people used the internet for. So this is actually kind of difficult to read for people who aren't used to reading math books. So you've really got to sort of like reading math texts and wanting to understand a lot of theory that goes into working out the particular problems and what is involved with the particular equations and formulas that are going to be used. Now, yesterday I did almost 2.5 hours total of Learn with Demoness. I think I'm going to make this a regular thing. I've been wanting to do a live, not necessarily series, but maybe a limited set of videos on learning stuff. And that doesn't mean that I'm going to teach you everything that I know or everything that I think I need to know. But more or less, I'm using this as kind of a creative outlet as well as a study time. Yesterday, I did my demon makeup while I was reading about the Pareto distribution off of Wikipedia. And the Wikipedia article for the Pareto distribution is much better than the Pareto principle article, which is absolute garbage. It needs work. I'm not saying it will always remain trash, but right now it's currently trash. It's as trashed as listening to Jordan Peterson try to talk about Pareto, and I have several clips in my shorts if you would like to hear what Jordan has said and how he has mistheorized and in error formulated his own theories and theoretical reasonings, which are false, for virtually his entire worldview, okay? I'm not going to get into Jordan as much in this video. Very interesting, though, to note that Jordan in the past, maybe he has gotten a handholding recently from a PhD holder that graduated from MIT. But I doubt it. I think what Jordan is very good at doing is only improving in as much as he needs before somebody brutally calls him out or makes fun of him for being totally wrong about the concepts, the mathematical theories, among other ways of attacking him being totally, I mean, just unabashedly idiotic about a lot of this stuff. And he claims he used to be a statistician. What he means by that is he used to do experimental work in psychology, but it involved a lot of stuff that had already been done before. Jordan has never devised an original like applied use application of statistics, okay? He may have figured out how to study people in an experiment and in the kind of experiment that had been done a million times before. The only thing he would have needed to do is change a few things. I'm pretty sure that Jordan has gotten away with publishing dozens of articles in that sort of vein, and now calling himself a scientist, thinks that he's really awesome at theory, when in fact, maps of meaning, his big theoretical contribution, it has gradually been debunked and disproven by articles in neuroscience, neuropsychology, cognitive science. It was never right as far as anthropologists are concerned. He made up so much stuff in that book that I'm not really sure why it was ever published. I don't understand how he keeps getting a free ride and he keeps getting away with not making an actual contribution to science, and is out here calling himself a scientist and not even being accurate about basic proven concepts like Pareto, and the difference between the Pareto principle, power law, Pareto distribution, etc. But we're going to get into some things today that I know Jordan didn't really study very well in school. Despite doing the statistics, I know he didn't really learn, because I can tell by the mistakes he makes, I know he didn't really learn the goods, folks. These are the goods right here. If you want to do anything with statistics, and that's not merely descriptive statistics. If you want to do anything like go into AI machine learning, if you want to do, and I don't want to call it the new kind of science, but if you want to do anything involved in social science or anything that already on its face is going to be using descriptive statistics, if you don't have these arguments in your foundation of your arguments and theories, if you're not reasoning along these lines, if you don't understand these maps right here, you're going to be in a sad state, like most of the infotainment media actually is in a sad state, unless you're, watching videos teaching you the math. But what winds up happening is people theorize like Jordan did without the real theoretical foundation. And probability is so much more and takes so many concepts and makes them all work together that it's unavoidable. You will be using it whether you know it or not if you do statistics like Jordan did. And he doesn't understand, it's like one of the main problems at the forefront of this sort of online lifelong learning MOOC massive open online course, open education initiative, sort of. I don't want to call it a revolution in science or education, but the movement of putting things on the internet for people to learn rather than just expecting them to learn in classrooms and that be the only way, and teaching them that they can, they don't have to have an authority figure in a classroom making them do things in order to actually get good at stuff. That's something I learned. And for people who are wondering, I learned this before it was even a thing, actually. And for people who want to know who the heck am I to criticize Jordan, well, a high schooler could debunk Jordan's college coursework. So, like, I think maybe you are the ones who need to take a step back. If you think you owe him something just because you have no credentials, do not expect that from everybody else. There are people out here who, unlike Jordan, can teach themselves things and get it right. Jordan, though, has proven time and time again for at least 5 years that he is incapable of understanding the maths, undergirding much of the things he's out there doing keynotes, claiming are his worldview. Okay? That is a fact. The other fact about Jordan not knowing anything is that, yeah, I mentioned this yesterday, but he basically degenerated as a scientist. And that was also another problem on the forefront, that there are too many alleged theorists who don't really understand the theoretical underpinnings of what they're saying, basically. They're out there writing fantasy, pretending it's viable for scientific thought when it's not. Now, some things can sound like science fiction and are viable for scientific thought, but there's a difference. There's a way to tell these takes apart. And there are ways that scientists can see that one of them is, something that science could achieve, and one of them is something that science has already realized is not achievable or erroneous. Jordan, though, he couldn't see that or do that for himself and his own theory. So it's not that any scientists were out there trying to point the finger at him 12 years ago, let's say, but maybe he was somebody in mind, and maybe the problem is much bigger than him, which is actually part of his outrage, his moral outrage even, which he can feign because he's just as wrong as a Robin DiAngelo, who also has a PhD, by the way. He's just as wrong as any alleged Marxist who doesn't understand social science. But I will say that there are much better social scientists who have done very good contributive work as Marxists than Jordan has ever done. And that doesn't mean that, like, believing their science and their methods or whatever, the way Jordan puts it, is the way that they really did their work. Okay, so I urge everybody not to listen to Jordan's interpretation of other scientists, even ones that you want to believe in and ones that have sold pop philosophy books or pop psych books like Jordan. A lot of the takes that those guys wait for in order to get published is, that a lot of the takes they wait for a kind of acceptability signal in order to publish are galactic and not properly generalized, and miss a lot of things that better theorists don't miss. And it's hard, okay? It is hard to write good theories and make good predictions that come true as a scientist. And you may think, well, scientists shouldn't be creating these questionable sort of trajectories or whatever, well, I think that's unavoidable. I think people in science are going to try to come up with, you know, a vision of the future. But they don't all do it. You know, they don't all do it. Some of them only do it once they get really good at seeing the future of their particular expertise. And some of that can be so boring and complex that it's never going to make the viral audience, you know, what it wants to be, which is appeased with easy information, you know, unloadable content, stuff you can relax to. And Jordan, for whatever reason, garners a lot of sympathy and support. I think because he has this way of tricking people. I do believe he's like a trickster, like the Jungian archetype, but I'll talk about that in a different video. But he has this very relaxed approach to what he wants to seem like very difficult material in his courses anyway, when in fact, what he's really doing is being overly ambitious, lazy, and what he does publicly anyway, which is making people feel smarter than they really are, simply for being taught by him, no matter what kind of garbage he's teaching them. I find that fascinating, because I'm not the kind of person who's going to make you feel smart. And I think that's because, you know, I'm not here to lie to you. I'm not here to make you think. Stereotyping people, for instance, is a great survival mechanism that you should just rely on all the time in order to navigate the world. You know, Jordan will do that. And he will put a lot of effort into that, and he has. And it makes people feel like they were right all along. I'm not going to do that for you. And I'm not going to do that for Jordan, because he certainly was not right all along. It's like by ignoring his own mistakes, people take this social cue that they should ignore his mistakes as well. And if they do that, they'll get the reward that despite their shortcomings, they can be just as allegedly good as Jordan. It's like, ooh, you know, because Jordan has basically just freeloaded and gotten away with it his entire career. And I think that that's very sad. I think it's a waste of time. I think it's a waste of money. I think it was a disservice to the students. I think he really had no real interest in many of the things he was saying he was interested in when he was at Harvard, which had a lot to do with the psychology of terrorism, which, you know, here we are 30 years later. And like, what has he done? What has he written, actually, about any of that and gotten published in a peer-reviewed journal? You know, there are interdisciplinary counterterrorists who are scholars and write counterterrorism journal articles for like perspectives on terrorism on the side of their science teaching or whatever it is that they do. They come from all different disciplines, and to approach the sort of understanding of terrorism and behavior of terrorists, the mind of the terrorist, the reasoning, the politics, culture, anything and everything you can think of, as well as generalizing terrorism, is a lot of that kind of work. And Jordan has done nothing, not a single thing. And I'm not going to pretend for him that being interested in that didn't make him attractive to Harvard when he was teaching there. It did. It's a fascinating crossover to think, yeah, you know, What is it? What is it that gets people into their political ideology? But Jordan can't. And I know that there are good math teachers who don't agree with saying somebody can't do something, but the man has gone an entire career, so I'm over it. He's gone an entire career and taken advantage of countless numbers of people, and now millions and millions of people um, who just don't get it and expect him to be the one getting it and think they're being spoon-fed how to get it. And no. Jordan is beyond a grift. He's beyond a guru. Jordan is this perpetual freeloader, like a psychopath. It's like, at this point, I think we could even call it pathological. He pretends to care when it gets him places. He seems sort of fascinated about some particular thing, but what he's really into is not something he's willing to build his life and his career around. And I think that thing is Russian literature and Russian culture. And I think if Jordan could go back and do his whole life over again as far as his education, that he would just find some kind of like Russian cultural program and learn Russian and study nothing but Russian history and Russian literature. And a happy man, and not this whining, crying, pretending to be sad about people old man that we see today would Jordan be, you know? He keeps circling back to Russia this, Russia that, Solzhenitsyn this, Dostoevsky that, and it's, he's studied that stuff for decades. I agree. He's maybe an expert at Dostoevsky, maybe an expert at Gulag Archipelago, maybe, but he cannot bring himself to be his passion. And he's saying, don't do that. And I think it really makes him unhappy. He has every freedom. He has, and now especially with becoming a millionaire, we all know he's very rich now. He can do whatever he wants with his life. And yet he thinks he should be out there exercising this kind of male archetypal theatric authority, which, quite honestly, like I stated, I believe makes him unhappy. And it's his choice. And he, tells people to bear their cross, blah, blah, blah. It's like, Jordan, are you serious? Like, people don't want you out here making up false theories just to bear a cross. Don't you see that's actually detrimental to society? I do. It doesn't make him a good person. He would be a good person if he were just doing what he wanted, actually, and enjoying the things that he was knowledgeable about and being accurate all of the time. But no, not Jordan. Jordan has to try to answer bigger questions that he doesn't know how to approach. He has to try to come up with theories that he never learned to formulate properly. He has to try to fool people. And for whatever reason, he doesn't think that that has an adverse outcome on his psyche. Is he just deeply in denial, or is he actually, in the worst way, enjoying his cross, which is to essentially miseducate? Because, if he were actually a passionate teacher, what would that say about him? I don't know. I don't know why he does this to himself. But it's not just himself. I can't look past the fact that he is feckless with the minds of millions of mostly men all over the world. As an educator, he should be ashamed of what he has done. And these PhDs from MIT economics, or wherever the F they want to come from next, who are going to laud him or try to just be friends with him or whatever, they should check their source before they go feeling snugly up to Jordan's channel. I know that Jordan has an attractive platform. Yeah, if you don't look into what the man actually says in his content, it's very attractive. You know, looking into, I guess, the people who make content against Jordan, and that none of them have as high of a credential as you, might make it seem so attractive that it just seals the deal. You know, well, no one with a PhD from MIT has rendered content on their channel that accurately disproves Jordan. It's like, I don't have a college degree and I disproved his model with a logical proof. So there's that. You know, self-taught person right here proves professor can't teach himself anything. And that pretty much means that everything he came up with on his own is wrong. And that's not a weakling. An intellectual weakling is what Jordan Peterson really is. And much of my channel is devoted to that, and this is still just kind of an explanation for why we're studying probability today. But much of my channel is devoted to debunking Jordan. Number one, because it's fun. Number two, because it's easy. Number three, because being a self-taught person who's better at theory than that guy, Jesus, who would not do that if they could? And also, my own work and my contributions to science cannot, it's not that they won't withstand Jordan. So I don't want you to get that idea. I don't want you to get the idea that for whatever reason, Jordan in his world out here, outside of academia, is somehow going to topple me inside anything I might contribute to science or academia. No, it's not that. It's that I'm willing to take it back to the inside. From the outside back to the inside. And whatever it takes. Take that as how you want to, but I'm willing to do whatever it takes to make sure that Jordan Peterson has a lasting known legacy among knowledgeable people, not his fans. That's not what they are, but knowledgeable people. That Jordan was never good at what he did as a scientist. Except for maybe some alcoholism papers that he got published, which were basic. And not that basic is bad. I like basic, but there's a difference between my version of basic and Jordan's half-assed version of basic, okay? Basic to me is learning the foundations and in a basic way. Basic to Jordan is mimicry, copying, like an artist. Copying somebody else's work, essentially. That's Jordan. He believes that's the art of the science. So, how the hell did I logically disprove him? Part of it is in this book. Probability relies on the set theory. Yesterday, I'm not going to do set theory in this video. Let's see. Yesterday, then again, maybe I just should. God, don't even get me started on Bayes' theorem and how it just surpasses Jordan. Everything he has ever thought of. He refuses to update his prior anything. His prior theory, prior hypothesis, prior take, prior view. He refuses it. Bayes' theorem is a massive part of probability and a massive part of science now. I have a whole book about scientific reasoning using Bayes' theorem. One second. Yeah, here it is. Scientific Reasoning, the Bayesian Approach. Highly recommend this book. This is a great book. This book actually strives to unscience some very long-standing statistical methods even, because they aren't really good methods in science. They're not the best methods anyway. They can be useful if you know how to make the arguments that they make. I think this sort of Bayesian movement, though, because it is a movement now, especially with machine learning and artificial intelligence, it has become a movement in its own right, since this method, this theorem, is extraordinarily useful in that domain. We want artificial intelligence updating its information constantly. Okay, we want it learning, actually, but without having to teach it like it's a creature, without having to teach it like it's a dog or a chimp, you know? And the way you do that is you do it mathematically, and you do it with probability. No matter how you do it, it's going to be with math and probabilities. So even the very basics of computational vision rely on organizational information, which relies on making something more useful to applying mathematics and probabilities to it. That's just the way it is in math and science right now. And Jordan doesn't fit in anywhere. He doesn't fit the mold. It's sad watching him talk about anything related to brain sciences whenever he thinks that that's going to be his useful part of a conversation. Like, oh, I just cringe every time I see it now. And I try, I try to see. He uploads daily, and it's really awful watching him flounder, watching him say something because he's expected to say something by men who believe him, and he thinks he should and ought to just say something because he's an influencer. It's like, Jesus, and we're teaching the children that that's what they should strive for? I think we should teach the children to be accurate, and that they're not going to be able to ride on the coattails of Jordan Peterson into influencer success. If they try to do that, they'll be cutting corners. If they try to do that as scientists, they'll be a laughingstock, especially nowadays. Jordan got away with it prior to even the dot-com bubble, prior to any of the explosion of the internet. Students today, not so much. I mean, we know they're spending a lot of time on TikTok, don't we, Matt Walsh? Well, if they really love those platforms and what they do for society, then maybe those students should look into probability. I guarantee you they won't regret it if they really are serious about computer science. Anything and everything to do with it, as well as any kind of data science, as well as any kind of really study of behavior. If you ask me, like, we've gotten to the point where we want to compare machines and humans, and we know a lot about the equations machines use. We don't know as much necessarily about the equations people are using, okay? I know that's a stretch for some. Math happening in your brain without your mind. Probability. All the time. All the time. Running in the background. You don't have to know it with your mind. Knowing it with your mind really helps. Knowing it with your mind will help your mind and your brain. In other words, what I'll just call the prefrontal cortex and the rest of your cortex connect with one another, okay? Imagine, think of it this way. Imagine not ever having practiced basketball, right? as a sport or a game. But knowing that if you just throw the ball at the hoop, it will go in sometimes, right? That you can figure out how to make a basket. Now, imagine being expected to play basketball, the organized game, but only really ever having learned that you know how to make baskets, right? Let's say you got pretty good at practicing making baskets, and now, you know, you can do that, but you can't necessarily play the game. That would make you a stranded player, a mediocre player in a lot of ways, a bad player in a lot of ways, a bench warmer probably in a lot of ways. And let's say you never learned how to play the game, right? But you thought, no, I'm a basketball player because I can shoot and it goes in at a high rate. Okay? It's like, you know, probability to some degree will help you play basketball. You know you've got to score baskets. You know they've got to go in more than they don't, or at least sometimes, right? That some of your attempts have to go into the basket, or you would never consider playing on a team despite knowing or not knowing the rules. Am I right? Okay, probability, very useful. You know, you think of these things, but you don't think of these things. Like, you know these things, but you don't know these things. And you can't assume that not knowing them with your mind is enough, but you also can't assume that what your brain can do without your mind isn't enough. That's very tricky, and it's tricky for brain scientists, and it's tricky for computer scientists. It's very difficult to talk about the similarities between, say, an algorithm and some process or mechanism, which is not even what you would call it. It's difficult. So, what do we want to do? What do we want to do? Learn probability stuff. There's all kinds of rules and principles. There's all this stuff. Oh my gosh. Oh my gosh. There's all this stuff. There's trees and triangles and coefficients and samples. Holy crap. And combinations and partitions. Oh my God, where do I even begin? Where do I even begin? I know what I want to begin with. I said it before, and then I said, maybe we should just start at the beginning, but I think I do want to continue with yesterday. Okay, so what we are going to do, because Jordan botches up descriptive statistics so beautifully, even though he used to do experiments with human beings, it's like he's still doing one massive experiment that is really not anything but finding out if he can make massive amounts of wealth off of the naivete of undiscerning, ignorant people. Anyway, I digress, but that's the truth. Let's see here. This gets a little bit advanced by variate data. That's a linear, and then we're going linear. Let me look it up, because it's not that Pareto is in here necessarily. We wanted yesterday, where were we? Where did we leave off? I read a little bit more after I hung up. I got through Price's law, Pareto, Zipf's law. Like I said, the Pareto distribution article is intellectually on another planet compared to the Pareto principle article in Wikipedia. And if any of you want to contribute to Wikipedia, I highly recommend it. Most of the math and science articles on Wikipedia are not that bad, but the Pareto principle one is just trash. Like, it is maybe the worst one I've ever seen. And I read a lot of Wikipedia articles because they're good practice, and then sometimes the fact that they are not that great helps, because then you have to learn to fill in the gaps more with your prior knowledge, and that can be kind of a test. I'm not saying that you should rely solely on Wikipedia at all. You shouldn't. You should pick yourself up a Sham's outline if you're, especially if you're taking a course, but especially if you want to really learn a subject, and what's involved in it. You won't regret it. Man, hang on. I'm not even an expert at this stuff. Conditional distribution. What did we get to here? Raw moments, variance, random variable, characteristic, and properties. Probability density. Oh, I bet that's in here. That's properly where we were. It's going to be under probably function. Let's see, 63. Axioms of probability. Finite probability spaces. This is one of those things Jordan can't make sense of. All right, let's just start with the introduction, chapter 3. The other two chapters are going to be set theory, which I do want to do, but I want to talk about my disproof of Jordan's model when I do that. And then the second chapter is something called techniques of counting. And that involves a lot of proof basics, basic proof type stuff, rigorous stuff. Even though it's basic, it's still rigorous. It's still like, if you don't understand how these things work, it could trip you up later. And some specific things absolutely will trip you up later, depending on what you're trying to pull out of your arse, the way Jordan does. Ordered samples, permutations, combinations. It's like very basic combinatoric concepts, binomial coefficients. That's something Jordan also has a hard time with. He can't seem to understand the difference in a binomial experiment and a Gaussian distribution, a normal distribution, I think. I don't think he has ever done any of this math, to tell you the truth. So, except for maybe some of the statistical stuff later on, which it's like, you know, if you didn't, it's not that you have to take calculus, but it's also like, if you didn't take calculus, I'm going to have a hard time understanding how you relate to the area under a curve, like the normal distribution. That's just the way it is. Did Jordan take calculus? Maybe once upon a time ago, Jordan took calculus, but I think it's the kind of thing where he lost it because he didn't really use it and never really understood how to apply it to statistics, unfortunately. Like maybe a couple of things. I'll get to that later. I'm going to read chapter 3, Introduction to Probability. Probability theory is a mathematical modeling of the phenomenon of chance or randomness. I love that. If a coin is tossed in the air, it can land heads or tails, but we do not know which of these will occur in a single toss, do we? We know it will be either, though. However, suppose we repeat this experiment of tossing a coin. Let S be the number of successes, that is, that a heads appears, and let N be the number of tosses. Okay. So by doing some subtraction, then we can figure out how many tails there were, right? That's what the prior chapter, that's kind of, I mean, it's more than that. It's more involved than the way I just stated it, but that's the kind of thing the prior chapter on counting. Because if you're going to count the tails, first you've got to count the heads, or if you're going to count the heads, first you've got to count the tails and the total. Boom. Then it has been empirically observed that the ratio F equals S over N, called the relative frequency of the outcome, becomes stable in the long run. That is, the ratio F equals S over N approaches a limit. That is so into calculus without being into calculus, and so into the normal distribution without being into the normal distribution, that it's like, whoa. This is such a much better way of learning calc or statistics before you actually do those. Okay. So relative frequency. That's important, and it's italicized in the book. What does that mean? That's going to be some number of occurrences over the total number of attempts. So, like they defined a success as a heads, landing on heads. We call that S. And then we put that over N. N is a common total variable. Variable, that means the total number of something for number. So how many successes over or out of how many total? And it's always going to be equal to or less than the total. You're never going to have more results than attempts, right? Basic stuff. All this stuff is so easy, except it's hard. Why is it both? How is it both? How is it so hard? Because people, I think, don't want to naturally explore what any of these statements mean outside of themselves. I don't know why that is. I don't know why people are like afraid to learn or afraid to have knowledge that isn't spelled out for them. But if that's you, you need to get over that, okay? You need to unlearn that tendency to only absorb or notice what you see in front of you, okay? It's better to see it in as many ways as you can, but as long as they make sense, and I mean as long as they're accurate. Saying something just makes sense is not necessarily accurate. Okay. If the coin is perfectly balanced. So we don't want a coin that's like a cheat coin. We don't want something that will always land on heads because it's weighted improperly, right? They usually call it a fair coin or a fair die, like if you were talking about a dice roll. You don't want loaded dice. They're called loaded dice. Loaded dice that will land on some number more frequently because of how there's some way of making the opposite side heavier within the interior of the object. If the coin is perfectly balanced, then we expect that the coin will land heads approximately 50% of the time, or in other words, the relative frequency will approach 1/2. What is that? How? What if you roll the die or flip the coin 1,000,000 times? How is the frequency going to be 1/2 if 2 is the total, but you did it 1,000,000 times? Because it's just a fraction, and you can reduce fractions, right? And this all becomes very complex with like very easy math and very basic stuff very, very quickly. I understand why people are intimidated by this, especially when they start reading words about math and it's not just, okay, here's a formula, work it out. That's easy stuff. That's, I don't want to call it baby math, but that's the lazy school teacher's way of teaching math. And I'm sure a lot of people have been subjected to it, especially if they weren't particularly gifted at math and exposed to better math education, or they haven't really done a lot of exploring on math YouTube. But alternately, Assuming the coin is perfectly balanced, we can arrive at the value 1/2 deductively. Wait a minute, wait a minute, wait a minute, wait a minute. Now we're getting into theoretical territory. Deductively? What do you mean deductively? That is, one side of the coin is as likely to occur as the other. But how do we have a 2 where there should be what number actually we did? And how do we have a 1 when we rolled this thing more than twice and maybe we got 2 heads twice? Or 1 head twice, which is what it would be. So maybe if we only rolled it, or maybe if we only flipped it twice, we got 2 heads. What if we got 2 over 2? Well, what then? It's like, okay, so the part you're missing is the approaching a limit, which doesn't mean what it seems to mean in language at all. Approaching a limit, wait a minute, a limit, don't you mean approaching no limit? Like approaching infinity? Boom. Yeah, actually, it does mean that. It does mean literally the opposite of what it says. Congratulations. Now you're a math theorist. Now you know. You cannot read language the way you want to. I said this yesterday. I made a very long-winded point about saying this yesterday. If you think you're going to get away with your preference for language and actually learn math and science by reading good ways that it is explained, you're going to be left in the dust. You will be crushed. Words are not going to mean what you think they mean anymore, okay? And it's going to be very particular. And you're going to have to understand bigger, more abstract, broader concepts than just the language of what it's saying. And you're going to have to learn to look at a word in a new way with a lot of information behind that usage. And you're going to have to learn to respect it. And if you can't do that, there's the door. You know, I'm not going to say you can't learn math and science, but you will be crushed. You have to be intelligent, and that means healthily skeptical, yet understanding of things that you will never change about this concept which has been, and it will never change, okay? The concept of a limit. You're not going to change that. Okay? Don't even think that way. It is not your subject. You are its subject. You will bow to it. Okay? You will learn that no one is going to necessarily teach you to learn this in a way that will work for you, your mind, and your brain together. You're the one, if you find any of this fascinating or interesting, you're the one who has to figure it out. Yes, in some sense, your way. And also by essentially submitting yourself to the greater good. Okay, this is like learning math and science is in so many ways like making this ultimate sacrifice of ego, because the language, first of all, the logos of this is not what you're going to think it ought to mean. If you just think language should be easy for people and make it easy for people to learn concepts, forget it. Forget it. You're maybe right about that, in the sense that this would be easier for people if a limit weren't called a limit, but good luck, okay? You're not going to change it. You're not. You have to learn, not necessarily to just be more flexible with language, but you have to learn, in particular applications and domains of math and science, there are words that are not going to bend to your will and your preferences, even if it would make a billion more people tuned into the subject, okay? That's a fact. Okay, now if you want to go ahead and devote your life to explaining and a career to explaining to the rest of science and math that, well, if only we taught it in this other particular way, like the whole world would absorb this stuff with much less effort, be my guest. That is ambitious. I think that it could be a beautiful thing if you were able to accomplish that. More power to you. I'm not, and that means information. I'm not going to put you down for it. But you really have to, let's face it, be passionate in order to achieve something that awesome and that beneficial to society and other human beings. So I think, you know, the point that Jordan likes to miss also about pursuing your passion is that most of those people like people actually a lot more than Jordan does, and are concerned about people more than Jordan really is, even though he just repeats the same stuff about them over and over again, if you haven't noticed, and refuses to better his own knowledge about them. If you're passionate, you don't stunt yourself, okay? I'm not saying you haven't discovered your passion already. I'm saying you maybe don't realize that the thing you could be passionate about, you could be passionate about. And I'm also not saying that you necessarily have to pursue a passion. You know, I'm not saying that. I'm saying, hey, if you find this stuff intriguing and fascinating and fun, who cares what it is? If it's a passion or not, you know, who cares? Even if you just like screwing around with it, doing it for the sake of doing it, even if you just like flowing with it, you know, you don't have to necessarily have a world-changing, game-changing, industry-changing, education-changing revolution going on in your head all the time in order to find this very satisfying. But you will, like I said before, you will have to subject yourself for the greater good, even if it has nothing to do with anyone else but you, okay? Although the specific outcome on any one toss is unknown, the behavior over the long run is determined. Right, the behavior. Okay, this is all very important. Every single freaking word. The behavior over the long run. What does that mean? Well, basically that means you can flip that coin 1 billion times and your outcome is going to be reducible as close to 1/2 or 1/2 the time it winds up being that you flipped a heads, even if you flipped 1 billion times. Why? Well, if your coin was fair, like we said, if your perfectly balanced coin, there's one of two options. If you apply randomness, which is a flip of a coin, okay, let's face it, if you flip that fair coin, there's one of two ways you can record the outcome of a flip, which is random, or at least pseudo-random. It means that the randomness doesn't favor any particular outcome. They will be as close to equal, or which means equally likely, as universally possible. Okay, that is a concept. You've got to remember that if you're into probability. The stable long-run behavior of random phenomena forms the basis of probability theory, okay? So, if two outcomes, and the randomness is also very important. This wouldn't be probability theory if it weren't for the randomness, okay? If you have two outcomes, but they're not really random, even if they're both equally likely somehow, but they're not really random, it's not, it depends on what it is, but it's not necessarily a probability, okay? Consider another experiment. The tossing of a 6-sided die. Probability likes to measure things that are reproducible and repeatable, which is why scientists really like it. It's a very, I'm going to say the word basic again, it's a very basic application of math and science, and it's fun, and it involves gambling. So yes, it's It's very, very popular among very smart people. Consider another experiment: the tossing of a six-sided die and observing the number of dots or pips that appear on the top face. I happen to have a big purple die. Boom. This is a fair die, at least I believe it is. I bought it from a regular game store. So these dots are called pips. And if you start calling dice dots pips and saying the word probability and long-term behavior of a die, people are going to start wondering, who are you? Okay. So, rolling a die, very, very much like tossing a two-sided coin, only it's like a six-sided coin. So there are 6 possible outcomes instead of just 2. And you can keep producing, by rolling, you can keep producing or flipping. You can keep producing one of those outcomes randomly. And over essentially theoretically infinite rolls or flips, every single side is just as equally likely as the others, okay? Same with the coin. But you can have pretty decently long runs and repetitions. You know, that's why in the theory it has to approach essentially what we would consider no end. And then we call that a limit. It doesn't make any sense, but it does. Okay, it's bigger than you and it's smarter than you. Again, as n okay, wait. Suppose the experiment is repeated n times, we did this before, and let s be the number of times 4 dots appear on top. So now we want the number of rolls that gave us a 4 on top of the total or out of the total number of rolls. Again, as n, the number of rolls, increases, the relative frequency, which was f equals s over n, which is a reducible fraction, of the outcome 4 becomes more stable. What does that mean? More stable. What does that even mean? You're rolling a die. What is stable about that? How often you're going to see it, and it being predictable based on the total number of possible outcomes is what that means. Assuming the die is perfectly balanced or not a loaded cheater die, we would expect that the stable or long run value of this ratio is, guess, if it was 1 over 2 possible outcomes for a 2-sided coin, for one side of a 6-sided coin, it's going to be 1 over what? The total number of possible random outcomes, which is 6 on a 6-sided die, right? So you're going to get 1 over 6. If you roll this if you roll this die to infinity number of times, you're going to be able to see that the number of times each side comes up over the total number of rolls is going to be roughly 1 over 6 for each, meaning they have equal probability, right? Very close to it anyway. It's never going to be perfect. Like, you know, give or take a few rolls, basically. Or if you have a long run right at the end of your trials of however many number of n. I mean, you could have a long run, but the idea isn't necessarily how many times, even though we're saying, look at n number of times you rolled it and count those actually. That's not going to make a difference in the long run. How many you roll doesn't make a difference if you compare that to rolling it an infinite number of times. So I could roll 2 4s in a row. And if I only roll this die 3 times, that's not going to look fair. It's not going to look like we can predict into the future that the 4 isn't going to come up more often than the others. Well, unfortunately, for that example, you need to roll it a lot more times to really see the way it behaves as a relative frequency, okay? It's called relative frequency because that equation F equals S over N is really only relative to the number you roll, okay? But as far as the probability itself and the behavior of that dice, or the die, one is a die, what you did doesn't matter. It's relative to you and what you rolled, okay? It's not necessarily indicative of the behavior of the six-sided die when you roll it a billion times. Let's put it that way. Okay, and we'd say the probability of getting a 4 is 1 in 6, or 1 over 6, 1/6 the fraction. 1/6. In a pie of 6 slices, it's one of them. Excuse me, more on that later. Alternately, we can arrive at the value 1 over 6 deductively. That is, with a perfectly balanced die, any one side of the die is as likely as any other to occur on top. Thus, the chances of getting a 4 is 1 in 6, or in other words, the probability of getting 4 is 1 over 6. It's like we just said that. Again, although the specific outcomes on any one toss is unknown, the behavior over the long run is determined. Now, that's a loaded word. What does determined mean? Hey, determinists may chime in. That's right, though. Essentially, applying randomness in a roll to a die means you're playing with this object that has a fate, okay? Now, each and every individual roll cannot be determined, but like it says, in the long run, the behavior is determined. That means there's a pattern. Whether you like that or not, Jordan, the pattern is determined. Now, Jordan says a lot of things about alleged patterns, like the feminine tendency to destroy reputations. It's like, well, Jordan, what does that even mean? The feminine tendency? Does that mean that you can just predict that women are going to do that? How? How do you do that? He made it up. Anyway, he made it up. It's a bad description. Because it's a quasi pseudo-scientific way of trying to meld an observation he allegedly has made of some cultural, maybe observable phenomena and probability. And he's a pseudoscientist. I mean, I can arrive at that just by reading these paragraphs of like really basic stuff. And if you can't, you should learn how, because you will do better in life than if you buy into his nonsense. The historical development of probability theory is similar to the above discussion. That is, letting E denote the outcome of an experiment, called an event. There were two ways to obtain the probability P of E. So, Jordan, what is the P of your E if we're talking about your experiment, which shows a feminine tendency to destroy reputation? What does that mean, first of all, in terms of the probability of it? And what is the probability of the feminine tendency to destroy reputation? Now, there's a descriptive way he could pretend, he could say, well, okay, take a sample, for instance, of How many women on Twitter? It's like, well, all right, now you're talking about Twitter, which is not really representative of all women in society or any feminine people in a greater society, first of all. So you'd be restricted to seeing a particular behavior on Twitter. Yeah, Jordan doesn't have an experiment, okay? He just makes the stuff up. I'm serious. What's your P of your E, Jordan? Is a good question to ask him. What's the probability? What's the probability? Also, one other way to look at it is if you take, let's say, 100 very feminine people, descriptively, you could maybe by questioning them, figure out how many of them have engaged in reputation destruction. That's one way to describe those particular people. And you might be able to find a pattern in that. That out of 100 very feminine people, some number, we'll say S of the N, which equals 100, some number S have admitted to engaging in, or let's say you have evidence through their Twitter account or something, or social media. Some number of them have engaged in reputation destruction. Okay, so now we're not just talking about feminine people. We're talking about feminine people who are engaged in reputation destruction on social media. That's not exactly the same thing as a natural, in the wild, innate tendency. It's not. Jordan pretending that it is garbage. But your P of the E, if your experiment is to determine how often the very feminine people, and then whatever even how even the feminine is quantified there needs to be very rigorous. Okay, Jordan doesn't know how to do any of this. He literally just makes stuff up, you guys, and then he thinks he's like a science god. He would be if he were right, but he's not. It's so stupid. So, there's two ways if you're going to do it in probability. A, the classical a priori definition. Suppose an event E, your experiment outcome E, can occur in S ways out of a total of N equally likely possible ways. Okay, so N is going to be like the number of attempts that you rolled a die. And S is going to be like the total number of sides of a die. Okay? Then P equals S over N, which is essentially the same thing as saying the relative frequency is the classical a priori definition. Kinda. It's the same formula with different variables. That makes it easy, but in the languagey theoretical part of it makes it more hard. Why are they the same? Why are we assigning different variables and using different words now for the same thing, basically? Why are we saying it two different ways? Okay? Food for thought. Get it? You gotta really like reading this stuff to understand it and want to understand it. And then there's B, frequency, or a posteriori definition, and this is going to be essentially the same thing that we just said twice to mean different things. But suppose after n repetitions, where n is very large, an event E occurs S times. Then P equals S over N again. So it's the same thing. Mathematically, very basic, very simple. Theoretically, it's like a whole new ballgame for people to think about stuff this way. Both of the above definitions have serious flaws, and yeah, the classical definition is essentially circular, since the idea of equally likely is the same as that of with equal probability. So it's like I'm saying, we're saying the same thing twice, which has not been defined. The frequency definition is not well defined. That was B. Since very large has not been defined. Right. So this book likes the original way that it explained it, which was relative frequency. But it knows you can't just think the relative frequency is indicative of, for instance, whatever very large could mean, as far as your N. So both of the above definitions have serious flaws. We read that. The modern treatment of probability theory is axiomatic using set theory. That is like way over Jordan's head. So far over Jordan's head that his models are logically disprovable from maps of meaning. Pretty much all of them. Some of them are easier than others because he attempted to make a mockery of set theory, basically, in my opinion, if you ask me, because his models are so poorly done and attempt nothing mathematical, probable, or even usefully theoretical, but I digress. Okay. So we don't know what very large means, but we know that the relative frequency over the long run, or essentially as it approaches infinity, is going to wind up giving you equal probability for a two-headed coin and a six-sided die. Has it really spelled that out just yet? Not really. I've already read this though, and I'm cheating for you. Excuse me. Okay, so what does that mean though, set theory? What does that mean? The modern treatment of probability theory is axiomatic using set theory. What is a set? Well, that was the first chapter of the book. I'm not going to read this chapter in this one. I want to go, like I said, I want to go over the disproof I did of him. But a set is going to be more scientific than people realize it is on its face. A set is going to be a way of discerning a category of things, which is beyond a descriptive way of, let's call it, isolating a group of things that all share something that has to be exactly the same. Okay? Or let's say above or below a certain parameter, quantifiable parameter. So, for instance, we could say there's a set of all animals whose maximum weight is below 100 pounds. True. Most songbirds don't weigh over 100 pounds. You could include all of them, but you can't include elephants and big cats, right? You can include virtually all insects in there. Now, the problem with this is that whether something is 100 pounds or not is totally arbitrary to the taxonomy. But second of all, we don't really have the ability to name all species on Earth that meet the criteria. So we won't have a very well-defined set because we won't know every single element that could be contained in the set. So that gets deeper into set theory than I want to go in this. But essentially, a set is going to be a collection of something and or a category of something. It's very useful to categorization. It sometimes is the most basic type of categorization, as in this die is a set of 6 sides, right? But each side has its own respective value. There's no repetitive values on the sides. Okay, I don't have 2 1s. I have 1 1, 1 2, 1 3, 1 4, 1 5, and 1 6. They make up a set of 6 sides, which makes up the die. Boom, that's a set. But all those elements have different values. So why would they be in the same set? What is exactly the same about them? If you recall, what is theoretically exactly the same is their relative frequency in the long run, or as the rolls approach the limit. In other words, once you approach an infinite number of rolls, theoretically infinite number of rolls, your probability of rolling each side should be pretty much 1 over 6. Very close to it. Close enough. Close enough and repetitive enough and reproducible enough that it's satisfactory, okay? So, okay. So we're going to say, specifically, a mathematical model of an experiment is obtained by arbitrarily assigning probabilities to all the events, except that the assignments must satisfy certain axioms listed below. Naturally, the reliability of our mathematical model for a given experiment depends upon the closeness of the assigned probabilities to the actual limiting relative frequencies. That's another way of saying everything I just said. This then gives rise to problems of testing and reliability, correct, which form the subject matter of, guess what, statistics, which is what Jordan claims to be an expert at. And he's not, because he doesn't know jack. He doesn't know jack about probability. If you don't know jack about probability, you aren't worth jack as far as statistics. Even if you think you do all the good methods and all the good testing and all the good intervals in statistics, you are trash if you don't do your probability right. And if you make probabilistic mistakes and then can't discern them in language and in your theories that you come up with on the fly to impress the boys, you are trash. Sample space and events. The S of all possible outcomes of some experiment is called the sample space. All right, so now we're talking about a set. That's exciting. I'm really excited. The set of all possible outcomes of some experiment is called the sample space. What does that mean? What is the all possible outcomes? Does that mean 6 sides on a die? What does that mean? A particular outcome, that is, an element of S, is called a sample point. An event A is a set of outcomes, or in other words, a subset of the sample space S. Oh my God, what does that mean? What is a subset? Okay. So we've got an event. Now we're calling our event A, not E. Why would we do that? You know what I mean? All this stuff will just like enrage some people, I think. People who want to be very particular. And also not bow to the particularities of math and science. An event A is the set of outcomes, or in other words, a subset of the sample space S. The event A, as an element of the set, consisting of a single point, A as a subset of S, a single point subset of S, is called an elementary event. Okay. Remember what I was saying just a few seconds ago about how this is a set of sides? Well, guess what? Let me blow your categorical minds really quickly with very basic stuff. This is so valuable. Like, knowing really basic things that can debunk whole decades worth of career theorizing by grifters and freeloaders like Jordan is so mind-blowingly fucking awesome. You can't deny that it's awesome. Okay, you can't deny that being able to do this and start seeing the mistakes that professors make in 400 level classes at very nice colleges is like kaboom. You're the god now, okay? And you should tell your teachers they're wrong when they're wrong. I am vehemently in favor of that. Go forth and disprove your teachers who are wrong. They're not all wrong, but there are some wrong ones, and Jordan is at the top of that. Ooh, he's at the top of that list, and people don't want him to be wrong. They just want what he says to be right, and so they don't care to know, okay? But, okay, with the die, what have we got? 6 sides, all equally likely. All right, so in a set, which is the collection of items or elements is what we'll call it, the die is a set of 6 sides. But since each side has an individual value, they can be categorized within the set as each an individual subset of the whole. Now, since they're all equally likely, they're all in this set containing 6 sides. But since categorically, or you could say subcategorically, they are each individually unique, they are each individually their own subset of the set. Boom. Okay? I hope that makes a little bit of sense. When I cover the set theory, maybe I'll read that tomorrow, maybe later in the week. I don't know. I'm flaring. We'll see how I feel. Then we'll go over more of the math basics of what is a subset. And, you know, I have to think about it because I have to print out my disproof, I think, if I'm gonna do it live, and I'd like to do it live, so I think I'm gonna try to print that out. Okay, I'm just talking right now. Okay, so if you don't understand relative frequency and how irrelevant it is actually to the long run of an event, like rolling this monkey here, you're not gonna be very good as a scientist. And if you can't take descriptive statistics for what they are and stop coming up with nonsensical theories based on them, you're going to be useless to science the way Jordan is. And that's not a joke. That is precisely what he does, okay? And precisely why he is an arse. Okay, so we've got our sample space, which is all the possible outcomes. And this is going to get very interesting very quickly when you start modeling experiments as sets, your sample spaces, trying to show what that actually means in terms of the set theory. There's proper notation for that. I'm not so much going to get into showing you the proper notation. I wanted to focus on making this more verbal, and less visual for people, because I think that people get verbally caught up in the lies way too easily. So showing you something verbal, obviously you're going to see this too, but showing you something verbal like this, where I'm not necessarily showing you how to write it out, might help you gain some confidence in that you can too just listen to what I'm saying, grasp some of these concepts without really knowing how to read them or what they look like on paper, and still pick apart bad arguments, bad debate points, and bad theories. It can be done. Just, you just have to want to do it and pay attention and grasp it. So we've got our sample space, our sample point, and an event, which used to be E, but now it's A. the event A is now called A because we're referring to it as a set of outcomes, okay? In other words, a subset of the sample space S. The event, okay, we read this, A consisting of a single point, A subset of S, is called an elementary event. Also, when I do the set theory chapter, I'll show you some notation. The empty set, or the null set, and S are subsets of S. The null set is basically a subset of every set. And a set can be theoretically empty by containing the empty set. But a set that contains nothing, including not the empty set, is not a real set. Not in this classical set theory anyway. Let's see here. Yes, the empty set is sometimes called the impossible or null set, and S is sometimes called the certain or sure event. What was S again? S was the sample space. Events can be combined to form new events using the various set operations. Wow, have I really been going for an hour and a half? That's amazing. All right, so I'm not going to go for very much longer. And I'm really glad I did this, because this really wound up being more of a build-up to me talking about my disproof of his model, which a high schooler could debunk if they had a Shams outline. This is not a joke, you guys. Okay, we're looking at various set operations that can combine events to form new events. So we're looking at the events now, though, as sets. And what this is essentially saying is that, yeah, you can combine sets to make new sets. Yeah. But they got to make sense. You can't just willy-nilly do these things. You can't just say things like the feminine tendency to destroy reputation. Like, what do you mean the feminine? Are you saying that, like, anyone who's feminine does that? What are you saying? That it has a high frequency among feminine people? Where did you learn that? What, you've just seen it? You've just seen it. But you don't know exactly if it's a feminine tendency, or if it's a tendency from people who have, for instance, all experienced something in common, which would make those people a subset. You know, feminine is not the only criteria for a set there. And that is a bad take by an alleged scientist to I mean, it's a farce. Jordan is an asshole who takes advantage of stupid men, mostly. Okay, so A, union B. We're going to talk about union and intersect and complement here. A union B is the event that occurs if and only if, which is written IFF, as if it's if with two Fs. Good luck not knowing what that means and trying to figure it out just by reading this the first time. If you're going to do this, I highly recommend listening to me, because I'm telling you all the little tricks and treats and giving you all the cheats and Easter eggs and everything else that you could ever want reading this stuff, because I know this stuff and it's not that hard, honestly. A union B is the event that occurs if and only if A occurs or B occurs, but the or there is inclusive, so that means or both. Also, a nuance. I don't think any particular group of people has a hard time with this kind of nuance. But there are ways of using the word or in theoretical writings like this. Explanations of theoretical writings, even. And sometimes or is inclusive and sometimes or is exclusive, meaning or can only be one or the other thing. Okay, usually with set theory, when the word or is used, it's mentioned as or inclusive rather than XOR, which would be exclusive, like I said. Okay. A intersect B is the event that occurs if and only if A occurs and B occurs. Okay. I'll show you when I cover the set theory what that looks like. A complement is the complement of A, and is the event that occurs if and only if A doesn't occur. Okay, so that's tricky. A can still occur, but this is the event that is not A. What does that mean? So then why would they say A does not occur? Because honestly, for there to be a complement to A had to have occurred. So that's a little bit tricky. I'll give you language folks out there, the language pirates, I'll give that one to you because that is very tricky for people who are just incessantly relying on language and verbal comprehension. Man, yeah, you've got to have some pretty rigorous verbal comprehension to really be learning this simply by verbal comprehension. It's confusing. And if you're learning it from a teacher who isn't thinking about people and their particular needs and stressing to themselves like I do, that not everybody's going to get you. You got to think about the way people are, that you've seen them be in the best you can in order to convey this information. If you really want them to learn it, instead of just trying to like outsmart them and trick them and prove your authority and your status and your credentials are worth putting you in front of them. And like Jordan does that, okay? I don't do that. I'm nice. Here, if and only if is an abbreviation of if and only if. Okay, that's an aside. Events, A and B, are called mutually exclusive if they are disjoint. That is, if A intersect B equals the null set. Okay, so if there's nothing happening at the same time, no two events, or the two events don't occur together, then their intersect, or the space they share, would be the null set. And yeah, there's some interesting ways of showing that in notation. In other words, A and B are mutually exclusive if they cannot occur simultaneously. Right. 3 or more events are mutually exclusive if every 2 of them are mutually exclusive. So what does that mean? That's kind of tricky as well. 3. Okay, well, how many groups of 2 are there with 3 things? That's what this is getting into. All right, you've got a 1 and this one, and you've got this one and this one, and you've got this one and this one, right? Do you have any more distinct groups or sets of 2 consisting of the pair subset, the unique pair subsets? Think about it. Think about that. That's your homework. Think about that. Right. That's interesting. Because that's saying 3 or more events are mutually exclusive if every 2 of them are mutually exclusive. What does that mean? Oh my God. Like the theoretical potential when you start learning probability is just, it's literally exponential, and it's so intense. So here's an example. This would be your experiment. You want to toss a die and observe the number of dots that appears on the top face. So what did you roll? And the sample space S consists of the 6 possible numbers. That is, so the sample space S is a set, like I said before, of 1 through 6. So each individual element It's like a list of 1, 2, 3, 4, 5, 6. Think of it as a list. But it's technically a set of elements. And let A be the event. So this is a way of objectifying like immaterial things. Think of it that way as well. Let A be the event that an even number occurs. B, that an odd number occurs. And C, that a number greater than 3 occurs. Oh my God, how would we know? How would we know? Well, we can know these things because we know what about this? That 1/6 is what our outcomes should reduce to over a long run for each side, right? That's so important. You can use that by, let's see, you can use that whereby starting with something basic to help you figure this out without jumping right into a formula. Sets are good for that. Sets help you sort of visualize not necessarily all outcomes of every kind of experiment, but for something basic and yet complex, which is what complexity theory is really all about. It's not really about insanely complex things. Those things only become insanely complex because they are basically complex. That's food for thought right there. Let A be the event. Okay, so A is going to be even numbers. Okay, even numbers of the 6-sided die. We know the 6-sided die is the set of 1, 2, 3, 4, 5, 6, each individual side, right? The even sides are 2, 4, and 6. Those are even numbers. You know what an even number is, I'm assuming. If you don't, you need a number theory lesson, and I'm not going to give it to you right now. B would be the odd numbers, which are 1, 3, and 5 out of 6, right? So now that's 2 sets. But if you notice, adding those sets together would give you the whole original set, right? Am I right? Am I right? Yes, we'll get to that. C are numbers greater than 3, or elements with a value greater than 3. Now that's quantifiable and countable. And 4, 5, and 6 are all element values in the set of a die that have a value greater than 3. There are no more. There's no 7, there's no 8, there's no 9, there's no 3.5, okay? We're still working with this set right here. Okay, so if you've now been able to discern the evens, the odds, and greater than 3, you should be able to deduce the set of sides less than 3, not including 3. Ooh. What's that going to be? 1 and 2. What's it going to be if it's inclusive of 3? So less than or equal to 3. That set is going to be like a list. Think of it as a list of the elements, the 1 side, the 2 side, and the 3 side. 1, 2, and 3. Right. Okay. So then A union C. Oh my God, what does that mean? Well, remember A was evens, 2, 4, and 6. C was greater than 3, 4, 5, and 6. What is union? What does that even mean? It sort of means added together. Think of it as a way of combining or adding, but think of it, if you're going to use those terminologies, let's say, if you're going to use the words added or combined, be flexible in that sense. Because union is, in a way, those things, but in a way, not those things. A union wants to account for repetition. So you're basically going to cancel some things out. it involves addition and division in a way, and I'll get to that. The event that an even number or inclusive, a number exceeding 3 occurs is what A union C is. Now, my God, how is anybody supposed to think that way? Right? A union C, you've got the evens and you've got everything greater than 3. Well, that means that, like I said, some elements are going to repeat or occur more than once in that union, but you don't really include them more than once as elements of that set union, which is now a new set. You don't repeat them. If there were 2 sides of a value 6 on this die, it could be different, but it's not. So we're still going to be relative to our original set of this die. Okay, we're never really going to exceed anything that is contained in this set, the original set that we are working with the subsets of, okay? You can't make more out of the subsets than is actually contained within the set. That is part of the set theory rules. I'll get to that later. All right, so that's why we now have this fancy pants language of A union C, which is combining and or adding, but also dividing by the 2, the 4, the 6, and then the 4, the 5, and the 6. So we've got 4 and 6 twice. So we don't need to do that, like I said, in this set of A union C, which is going to look like the 2, the 4, the 5, and the 6. They only occur once in the original set, even though you can put them in many subsets you could devise out of this die, out of the set of 6 sides of this die, which is also the set of 6 subsets, each with a different value, each element in the original set being a subset of a different value. A union C, the evens and the greater than 3s. In the set, the proper way to count the elements is just by how many times they occur in the original set. So if you are A union, if you are adding or combining in that colloquial way I'm using, A union C, you do wind up with the set 2, 4, 5, 6. The event that an even number or a number exceeding 3 occurs. Why is this set the event now? Why? Well, that's an interesting question. Because remember, we are saying now that an event is the set of outcomes. And since we want to know how to see what possible outcomes are based on our specifications on a set, or whatever we're asking this magical set, we can make a new set. And we can do that by using union, intersect, and complement, which I went over. But this was the union example, the union of the evens and the greater than 3s. You can write it out if you wind up doing this on paper anytime. You can wind up writing out the elements repetitively in a set, and then you have to realize that you have to cross the second occurrence of each repeated element out again. Why? You should know this by now, because they only occur once each. If we're talking about the die, the 6-sided die, we have 6 distinct individual sides, each with its own unique value, okay? So, A intersects C. Ooh, what is that? A, the evens, intersect C, the greater than 3 sides. So what does that even mean? That means we want both arguments, parameters met in our new set. We're making another subset, right, out of this. So if we're going to do that with the evens and the greater than 3s, we're combining even and greater than 3. It essentially means and. Even and greater than 3. Well, that seems logical. If it's even and it's greater than 3, and it's from the set 1, 2, 3, 4, 5, and 6, you know it's not 1, 2, and 3. 5 is odd, but it's greater than 3. But you need greater than 3 and even. That's what we're asking for. So what are we left with? 4 and 6. It's really good to think about this stuff. The event that an even number and a number exceeding 3 occurs is the set A intersects C, which was evens intersect greater than 3, out of 1, 2, 3, 4, 5, 6, 4, and 6. That's what you wind up with. Basically a set of the elements 4, 6, or a list of 4 and 6. List is a colloquial way. It's list I'm telling you to think of it as because it is essentially a list that can't have anything repeating as if it didn't repeat in the original set. But a set is a set is a set, and it's much more involved than just simply making a list. But seeing it as a list is like, you know, the beyond basic way of conceptualizing what in the world even is a set. How do you break an object like a die down into a set? You make a list, first of all. If that helps, do it that way. I think that it does help. It's sort of like a list is a preset in my book. It's like, you know, what kind, you could even make a list of the possible categories of things. And that is very helpful if you can figure out how to think about it that way. And if you do these kinds of basic problems and think about this kind of theory, maybe you'll develop that skill. But it's the kind of thing that you, even if you take this sort of class in school, you have to do this. You have to work at it. It's never, like, you're never going to take a course on any of this kind of math or science where everything is just spelled out for you like you expect it to be on YouTube. I digress. I hate to be the one. Note that A and B are mutually exclusive. Right. Because of what? B was the odds, A was the evens. So what does that mean? There are no odds that are evens. There are no evens that are odds. Each subset, even and odd, should be mutually exclusive, meaning contains no shared elements. Okay, that is that A intersect B is the null set, or the set of nothing, or a set that equals a set of nothing. Because, in other words, an even number and an odd number cannot occur simultaneously. That's what I just said. But I said it differently. But it meant the same thing. And you've got to figure out how to do that. You've got to figure out how to say the same thing differently. In other words. Okay, so here's another experiment. Toss a coin 3 times and observe the sequence. Oh my God, what is the sequence? Well, the sequence is going to be the ordered outcomes of those flips of the coin, the tosses of the coin. If you're doing it 3 times, do you unorder them? No, you don't want to unorder them or record them out of order. Like, for instance, if you flip heads, heads, tails, you don't want to claim that the first outcome was tails, and then you flip 2 heads. So, flip, record, flip, record, flip, record, boom. Now you have a sequence of 3 flips and 3 outcomes. And you're a fucking scientist, basically. My God, you're more of a scientist than Jordan, if you can do this, if you can pull this off. Toss a coin 3 times and observe the sequence of heads and tails that occurs. That seems fairly straightforward now, right? The sample space S consists of the following 8 elements. Oh my God. That's complex. Now we've blown our minds. We've flown the coop. The sample space S is going to be what again? A set of what again? Possible outcomes. This becomes very involved and very complex very quickly when you start dealing with something like even a 6-sided die and the possible outcomes of some, let's say, number like 3 rolls. This is 3 tosses of a coin, and there's only 2 outcomes. So, what is that going to look like as a set of possible outcomes? And what is that even asking for? What it's asking for is each possible sequence of 3 flips and the respective outcomes that are possible. So without repeating in the set. And that's going to look like you could flip for 3 flips. You could flip 3 heads in a row. Heads, heads, heads. But you could also flip 2 heads and then a tail. But you could also flip a heads, a tail, and a head. But you could also flip a head, a tail, and a tail. But you could also flip a tail, a head, and a head. Or a tail, a head, and a tail. Or a tail, tail, and a head. Or a tail, and a tail. Ooh, that's hard. That's getting into the hard stuff right there. Thinking about all the possible outcomes and the set of all possible outcomes. That's some wording that Jordan likes to use. Set of all possible outcomes, he says. He's never even done the basic stuff, you guys. The set of all possible outcomes of flipping a coin in a sequence of 3 times. 3 in a row. Right? Those are all the possible combinations of outcomes in a set. Each element is a sequence of 3. Yeah, that's complex, okay? So let A be the event that 2 or more heads appear consecutively, and B, that all the tosses are the same. That is a real phone. Okay, so A is the event that 2 or more heads appear consecutively. And B, that all the tosses are the same. What does that mean? Well, those are different things. Okay, so we want to think of these things as very, very distinct. A, 2 or more heads appear consecutively. Okay. They're making this easy by showing that set of possible outcomes. So for A, 2 or more heads appearing consecutively. What does that mean? That means 2 heads in a row, at least 2. So heads, 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 the first one, heads, heads, tails, and tails, heads, heads. Any one of those sequences where there are 2 heads in a row, in other words, not separated with a tail in the middle. So heads, tail, heads is not included in that subset A, which is the event that 2 or more heads appears consecutively. Okay, B is going to be all tosses are the same. What that's asking for is the sequence of head, 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 and tail, tail, tail. Okay, so now we have all the 2 consecutive heads toss sequences and a different category, B, which consists of the 3 in a row. 2 sequences of 3 in a row. And you should see that because there are 2 possible outcomes on the coin, heads and tails, that if you're going to have a sequence where all tosses are the same, a sequence of 3 where all tosses are the same, there's only going to be heads, 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 and tails, tails, tails. There's only going to be 2. If they're all the same, and there's only 2 possible outcomes on the object, the original set itself, okay? Think about it. The more you read about this stuff, the more you sort of read repetitive information regarding these kinds of things, and the easier it gets. So then A intersect B equals heads, heads, heads. What does that mean? Okay, so A was heads, 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 tails, and tails, heads, heads. B was heads, 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 and tails, tails, tails. So intersect, what does that mean? What do they share? What do each of those contain? Which element repeats over the 2 categories? Which element is assigned to both of those subsets? Right? Which element is contained in both? And that's heads, heads, heads. Because heads has 2 heads, heads, heads has 2 consecutive heads, which is what we asked for with A. And since B only contains heads, 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 or tails, tails, and tails, 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 or inclusive, heads, 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 or tails, 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 heads, heads, heads is in both. Nice. So it's the elementary event in which only heads appear. The event that 5 heads appear is the empty set. I don't know why they put that in there, but that's so interesting. So then they just toss in this extra. Well, we weren't asking for 5. We were asking for a sequence of 3. So what is it telling you by saying the event that 5 heads occurs is the empty set or the null set? What does that mean? Obviously, it means not just for 5 heads, but for any number greater than the sequential value, which is 3, because we did 3 tosses. We did the potential outcomes of doing 3 toss sequences, right? We did the sequence of 3 tosses and all the possible outcomes of it. So I'm just going to keep repeating myself, even though I'm saying things differently. I'm saying the same thing. I do that a lot because it really helps understand theory. And like you'll be much better intellectually if you can do that. And not get stuck on language, but also learn to respect words that are powerful information, like this word event. The event that 5 heads appear is going to be the empty set. Well, I could basically derive a rule then from that, in that if it's asking for an event whose value of trials or tosses is greater than the sequential, that it's always going to be the empty set. Do you see why I would say that? Do you understand why I would do that? It doesn't say to do that. It's not telling me that at all, but you've got to figure it out. You've got to start inferring the rules. The better you get at that, the better you'll be at math and science. So here's another experiment. Toss a coin until a head appears, and then count the number of times the coin is tossed. Okay. That's a good experiment. So what you do is you just flip until you flip a head. How many times did you flip until you flipped a head? Up until and including the first time you flipped a head. The sample space of this experiment is S equals, the set 1, 2, 3, to theoretically infinite. Now, that's also something very confusing and may seem like garbage to people because you know, if you've been paying attention, that if you're flipping a coin, if you flip to flips are going to look pretty equal in the long run. So you have to infer that you'll flip ahead before some number, you know, that you won't get past some number that you're not never gonna flip ahead all the way to infinity, right? But infinity can refer, in this case, because the way it's written in the set notation, to the case when a head is never flipped, never appears, and so the coin is tossed an infinite number of times. Since every positive integer is an element of S, the sample space is infinite. That's just mind-blowing. Do you see why infinity is theoretical? Because it doesn't necessarily make sense, but it changes the way you have to think about particular representations, models, problems, equations, whole areas of science, even subjects, you name it. In fact, this is an example of a sample space which is countably infinite. So that's interesting because sets are typically not countably infinite, okay? But since this is asking for something that could be theoretically infinite, meaning you never flip a heads, which is probably unlikely, right? It's improbable that you're going to flip and never flip a heads. We don't believe in that. Yet we use, but then why are we doing this? Then why does it say that? Why even bring this up, right? Why even say, well, here you go. Now you have to use infinity. And we're going to tell you it's a limit when it's really an unbounded, unlimited quantity, okay? Everything is a paradox now. Why? Why is it all so ridiculous and confusing? Is it made to confuse you? Kind of. But these are complex, confusing things, and explaining them in a way that's going to make sense to you is not, you know, it's not what people who come up with this stuff think of. They think of ways of coming up with this stuff better than you. Okay, so they don't think about you and spelling it out for you. But that's okay. You need to learn that if you're going to have a countably infinite set, there's a particular way, or some particular ways of going about that. Okay. So go ahead and do your experiment, I guess. Take your coin, flip it until you flip a heads. And then count how many times you flipped it until a head appeared, right? Infinity is theoretical. No one in their right mind really expects you to take a regular coin and flip it to infinity and a head never appears. But we just learned for over an hour that that's really not a thing, right? But theoretically it is. Theoretically it is. That's what infinity is. It's this theoretical quantification, let's say. And sometimes you're using it, whether you realize you're using it or not. And sometimes you're using it and you're like Jordan and you don't make any sense. Experiment. Let a pencil drop head first, whatever that means, into a rectangular box and note the point at the bottom of the box. Oh, okay. So lead first, not eraser. Let a pencil drop into the box, and note the point at the bottom of the box that the pencil first touches. It's kind of a weird experiment. Here, S consists of all the points on the bottom of the box. Let the rectangular area, which is drawn in this figure, represent these points. Okay, so now we've got a weird physical space that we're working with for our experiment. And we want to let A and B be the events, or our sets, excuse me, that the pencil drops into the corresponding areas. Okay. So if you were to take, say, the space of this book, if you were to just lay this book down on the table, and say on top of it, you just draw a rectangle, and then you draw another rectangle that intersects it, has an area that they share in common, but they have their own they have their areas that are also separate of one another, not containing any part of each other. Then A intersect B is the event that the pencil drops in the space where the two other rectangles overlap, okay? It's not as hard as it seems. I think I can draw that out for you, though, because I don't really like, I don't really like the way, how small it is, basically. So how am I going to show you that? All right. All right, let me draw this for you. So let's just say it's a space the size of this notebook page, okay? And what we're going to do is we're going to say you're going to have a box, and the bottom of the box is the size of this notebook, right? And then in the bottom of the box, you're going to draw a square or two rectangles, A and B. Okay? So what it's saying is, and this, I know it's backwards, this shaded area is the part A shares with B and B shares of itself with A, right? And so A intersect B is this. And if we took our pencil or pen and we dropped it on this surface, boom, and it lands, if it lands and makes a mark, so we're dropping the pencil or pen, let's say, like point down, so it'll make a mark, and that'll give us a recording in our physical space here. If I drop it and that point makes a mark in that in that shared area, in the intersect A and B, then this whole, okay. What is the point of this? I mean, obviously we can understand that that's A intersect B. Oh, I see what it's saying. This is trying to have you think of points in a physical space that has a confined area. Like a confined area as a set of points. Okay, that's not usually how you think of a box or a rectangle, like if you took basic geometry, even if you did basic math in elementary school. What you probably learned was that you can take like the area of a rectangle, right? By doing what? Multiplying length times height or width or whatever. Multiplying the short side by the long side, right? But if it's a proper rectangle, you know that the two shorter sides are equal and the two longer sides are equal. And that if it's a rectangle, it has two sides of two different lengths each, and each essentially respective set of or subset of the sides contains two equal sides. Think of it that way now. You know why? Because this wants you to see, by dropping your pen onto a surface like this so that it like lands and makes a mark, you've now made a point in a physical space of, think of it as immeasurable points. Okay? How are you going to count all the possible points inside A, B, A intersect B, or even the whole space, which is the page size S? Right? Our sample space is S, which is that this thing could land, as long as this page had like sides up like a box, and we do this experiment right, and we drop this pen so that it makes a mark where it lands first and then falls down inside our box. We're looking at a lot of points here. This is not a big page, but that's a lot. That's a lot. You can't count how many points this pen will land on. And how do you count them on the whole page, you know, versus inside a confined area? And then even, you know, confined again within two confined areas. How are you going to quantify that? Oh my God, that's just insane. No wonder this stuff blows people's minds. You need to think about it that way. Because the sample space S in the, let's see here. In here, yes. In the sample space S, that the page size is an example, get this, of a continuous sample space. But wait a minute, how is this continuous? How is the size of a square or a rectangle in terms of how many possible points your pencil could land? How is it a continuous space? It's this big, right? Don't you think that that means there's some number of points on this page? Like we learned to multiply the sides to get the area, right? Of a rectangle. So how now are you telling me there's a continuous space of essentially infinite points inside this rectangle? That's just nuts. That's just nuts. You just broke the law. No, this is exactly why this stuff is so fun. Because you have to sort of unlearn things that you may have thought too hard about and stop thinking so hard. It's an example of a continuous sample space, which is a sample space. S is continuous, right? If it is an interval, or a product of intervals. In such a case, only special subsets called measurable sets will be events. On the other hand, if the sample space S is discrete, that is, if S is finite or countably infinite, then every subset of S is an event. What? That's just like saying two very contradictory things, right? What do you mean? Let's look at that again. It is a continuous sample space, whether we like it or not. But what does continuous mean? It's continuous if it is an interval or product of intervals. Now, intervals can be open and or closed. That's what it's not saying. That's what it's not saying. Okay? In such a case, only special subsets called measurable sets will be events. What does that mean? What are these special subsets? How come only they are events on our continuous space? And how come continuous? Okay, so how come continuous isn't countably infinite? Right. Because what did I say? I said it involves an infinite number of points, right? And in a way it does. But because it's an interval or the product of intervals. On the other hand, if the sample space is discrete, if S is finite or countably infinite, then every subset of S is an event. So what that means is if you could quantify the actual number of points on this page, if you could really count them, and then and the ones you count are the only ones that could exist, then S would be finite. Or countably infinite. So that's a contradiction of terms, countably infinite. You can't count to infinity. You'll never stop if you are counting to infinity. Okay, you can't, I say you can't do it, I mean, yeah, because you can't. Because infinity is this paradox, and it is. It's this paradox that basically means quantification never ends. So you can't really count the infinite. What you can do is rely on the theoretical quantification of it and apply that theoretically in models and in abstractions that become very useful. But you do not have to understand how to conceptualize infinity as a quantity. Don't try to do that. I mean, you can try, but then you need to stop. Like, you don't want to do that. You'll be doing that way too much. Don't worry about it. And then understand the difference between continuous and discrete. So what does that even mean? Well, our S on the page is a continuous sample space. And what does that mean? Okay. It's a little bit hard. What that means is A and B were the boxes inside the space, first of all, right? And those represent the events that the pencil drops into their respective corresponding areas of the rectangle A, the rectangle B. But if it drops into the area that they share, okay, now what are we dealing with? Like, we're definitely dealing with a rectangle that has a quantifiable area. But we're not talking about the area. We're talking about points that a pencil or a pen, the tip of it could fall onto. It's so extreme. Like, it's extreme. Right? And so that means something. That means something. Because what we're saying is, essentially, for that experiment that we did, if the pen or pencil falls outside, it really only asks for the intersect space. If it falls outside of that, we're not really counting it as an event. That's why we're saying that this example of the page sample space is continuous. We basically made a way to contain it, to contain the infinite outcome. We've put a border around it. Seriously, that's drawing a rectangle inside a rectangle does that on your physical sample space. It's just mind-blowing what it does. Like, how it means these profound things to draw a rectangle that overlaps a rectangle, if you're thinking about the points inside it. Okay. But, right, in such a case, only special subsets, A intersect B, which we know is a subset. We drew it. That's a special subset. So we're saying with that experiment, this is our special subset here we're counting. We're not counting anything outside of that. Okay? So that's a continuous sample space. And that's the measurable set right there. Measurable meaning if and when the pen or pencil makes the mark inside that area, this area which we could calculate by multiplying the sides, right? That's our special subset. That's measurable outcomes. We can see it fell in that space or it didn't. If it did, we count it. If it didn't, we don't. We're discriminating, you could say. But it's measurable. We've made a measurable space. We know it's measurable by area, right? We made a measurable space. And the only events we're counting are the ones that involve that inside that continuous space. Okay? But if the sample space is S is discrete, which this is not, that is, if S is finite or countably infinite, we're back to that contradictory term, then every subset of S is an event. So that would be like saying these rectangles don't exist inside here. Anytime you drop your pen or your pencil and it lands on whatever area, it's an event, but you have to consider the number of points inside that space countably infinite. So it seems like there's really no difference, right? It seems like there's really no difference in countably infinite for this whole space S and our intersect here. The difference is that we made it different. It's very arbitrary. The difference is really this sort of gerrymandering, okay, that we could do by redrawing these boxes. We could reconfigure these boxes and make them look different and draw different sizes or whatever, and say, okay, now we want this area here or here or here. But because we're specifying inside, basically a subset, which is it is, A intersect B is a subset inside the sample space. I'm harping on this because this concept is so fundamentally important. It's so important in science and math, especially nowadays. If you study anything like this in the future, you're gonna see this over and over and over again. You will see something called your sample space, and then ways basically you can divide it up, manipulate it, make subsets out of sets that you created or you devised or you decided or you knew some object would determine, whatever, okay? The sample space. Is it irrelevant to this? No. No. Not really. All it does is give you a hard, quantifiable region, area in this example that you're going to be operating within, and then on some subset. If we're talking about the continuous space. If we're talking about the discrete space of S, we would say the sample space is discrete by taking away those inner boxes and saying wherever it lands in that space, because it's a discrete space, counts as an event, not merely the intersect of these subspaces or subsets we created into the relevant event space, okay? But no, we admit we don't have a way of counting all the points. Yet we know, paradoxically, they're countably infinite inside that discrete space. Fall in love. It's the best thing you can do with your life. Probability. Just fall in love with it. Okay. So I think that is going to be enough for today. I read like a whole 3 pages of this book in like 2 hours. Yeah. Because I talk a lot, but excuse me. Actually, I think that was nice. I didn't even get to the stuff I was covering yesterday. Probability density function. And there's more on finite probability spaces. Infinite sample spaces. This book really likes that. It's going to get into more problems in the back of the chapter. The answers to all the exercises are in the book. Yep. And then the next chapter is conditional probability and independence. That's fun. So Jordan does know I believe knows what a conditional and an independent are. He should. Does he understand it in terms that this book would explain it, though? That I highly doubt. I highly doubt he has a very grounded theoretical understanding of even the most basic statistical arguments that he makes. I'm dead serious. He's a sad little weak thing when it comes to the laws of thought and logical theoretical foundations of probability, which forms the basis of statistics, by which the foundation is built upon the set theory. Up yours, Jordan. We'll see who cancels who. Damn right. It's me or you, bro. Bow out. everybody who's watching. I want to do more of these videos. I like this, but I'm probably not going to do more than like, 1 or 2 hours at a time usually, maybe up to 3. It may seem slow, but I hope it was entertaining. And now I'm going to do the YouTuber thing and say like and subscribe to this channel, like the video. The bell notification, I think, only really works for you if you seek out my videos on a regular basis. I'm subscribed and have hit the bell to several people. I still get in my feed channels I don't even subscribe to more often than channels I do subscribe to, because I use my own account to watch content that I refuse to subscribe to, like Jordan, and I pretty much watch something from him or the Daily Wire on a daily basis, and so that is virtually all I get. If that's not how you use the app yourself as a consumer of YouTube, I completely understand. If this is the kind of thing that you think more people should do on YouTube, which I think it is, like real dedicated, re-educating in a way that is accurate, actually, by the book, and I meant that dually, for the book. Get yourself a copy of the book if you want it. I don't have links or anything. This is not like a promotional of Shams outlines, although that would be an amazing sponsor. I think I'm gonna keep reading this, and maybe we'll pick something up later in my YouTube career as a debunker of all males who are wrong at all times in the continuous sample space of maleness, as well as the infinite feminine. Or is it? We can't really say that it is, can we? No, we can't. Can we say it's countably infinite? Maybe. I'm being funny, but we'll get back to probability density function for sure. I definitely want to get back to that. It's just that gets into calculus. Dear God. That gets into calculus. That gets into much deeper probability. It definitely gets into some things that Jordan takes advantage of misinforming people about, because he knows it's going to be very difficult for people to look past his good side in order to, attack for the bad or make fun of him for the bad. But I have no problem doing that. But I come from not a credentialed academic background. But I do come from a competitive learning background, let's say, and I am an aggressively self-taught person who has no college degree, but I've taken several MOOCs, and I watch some of the best courses on earth through MIT's OpenCourseWare, which seems completely daunting and absolutely unbelievably intimidating for most people. And let me tell you that depending on the class is what it comes down to. MIT OpenCourseWare has some great courses to just listen to if you don't feel like doing the problem sets. Fine. Nobody says that you have to do all the work, and that you should feel stupid or anything. Like, they want people to bolster their knowledge either way, whether or not you actually do the coursework, or you're like that guy, whatever his name was, who like did the whole degree in a year, which, no, you don't. I don't think you should do that. I don't think that there's that much value in doing it. I don't think that you're really going to have that good of a grasp and an understanding if you do it that way. I know I, for one, retain concepts better if I'm not solely relying on rote memorization. But it would help Jordan. So if you're a fan of Jordan, he shouldn't be afraid to, for instance, listen to my favorite OpenCourseWare course, which is The Human Brain, which just came out a few months ago. It was released. And it's, I believe, 2 or 3 years out of date because they don't have that course necessarily as an open courseware offering in the current semester for how it's being taught in the current semester. Well, anyway, neuroscience and cognitive neuroscience is what it's about, mostly cognitive, but experimental neuroscience, cognitive neuroscience, neuroscience from the outside, and not so much mice brains, but Nancy really tried to focus on experiments involving brain imaging and human brains. Which I liked, which is why I watched it. I think that she realized there was a lot of pushback from the students on doing mice experiments and chimp experiments, and yeah, but anyway, more about that and my contributions to all of that, which, not to toot my own horn, although that's what I'm doing, my contributions to all of that are actually massive, and in a way that scientists had no reason to expect, because I became a genius, an unlikely genius, and that's not something I was voted as, it's not something I self-labeled, that's what it's called, because of what I've done with my brain. I may seem stupid to people. Well, let me tell you that listening to Jordan's definition and version of what a genius has to be thought of is wrong. And if you really understand, for instance, savant syndrome, you'll know that geniuses can even have detrimentally low IQs and not be able to even care for themselves or tie their own shoes. And their brains can do amazing things that theoretically we would never have conceptualized human brains being able to do, in a way that can communicate to us and allow us to communicate our brains with language. And there are autistic savants who, you know, break the mold of that notion all the time. What I did, though, was I broke the mold of the mold breaking and did something nobody even expected a savant with an IQ of 60 to be able to do. And here I am, using very adequate language skills, actually, with, you know, obviously some IQ points on my side, right? I'm fairly pretty good at abstraction, so, like, I'm not some average IQ joke, you know, that's gonna fall for Jordan Peterson, first of all, because I look at his abstractions and I look at the things he's doing with it, and I know that he's full of crap. That's really all you have to do. You don't, you know, don't even look at your IQ score. I don't want to deter people based on that. You can learn to see through the crap, the BS, the ways that men like him take advantage of people like you, and even people with PhDs in economics from MIT who look the other way because they don't think that he's ever going to do anything so poorly abstracted as the things he has actually done, and they don't have time to watch 100 hours of his content, and they miss these things, and then he fools them into interviews, and he'll say things that aren't too misleading. He won't repeat things that might not be true. He has a way of making decisions about what he says and what and who he says those things in front of, that saves him from ridicule. He's so good at escaping it. That doesn't mean he's good at the things he purports to be good at. It doesn't mean that any of his theories make any sense at all. And they mostly don't. I want people to be able to learn, even if they are average, even if they are below average. I want people to be able to learn that they can, even if they don't grasp every single thing and aren't interested in this and pursuing any of this, they can learn there's a way to see through him. And even if you learn just that there is that way of doing something, it'll make you a healthy skeptic. You know, once a professor starts bringing up his own abstractions, he better have some very nice theoretical underpinnings as far as I'm concerned. That is what I look for nowadays. Anyway, you know, I didn't think I was going to have to be such a hard ass about it until I encountered Jordan. You know, and it did start, of course, with this sort of uproarious nonsense of people getting upset about their feminist professors teaching blah, blah, blah. And I was like, okay, you know, like they're not teaching, that's not a science class. Like, what do you expect them to be teaching science? And there were some people who got offended, right? That some subject matter was being covered in a non sciencey way in these theoretical takes, theoretical. From the beginning of all of that, I was one of these people who was like, you know, if this is what feminism wants, I'm not a feminist then. I'm too intelligent and I'm going to be a scientist. On the other hand, now having said that, on the other hand, I am not an empathy-free dictator, tyrant, fascist person who can't see people and doesn't care about people and doesn't have my own personal experiences that have been detrimental to my life and my health because of men mostly. And it's not that I haven't experienced the full breadth and weight of what men can do destructively in society. It's not that I haven't felt the ultimate tragedy of the things that I've felt, you know, that have been tragic in my life. Those things are immense. They are injurious. They have caused damage. I will say that I have been a victim of things. I do not think that I have victim mindset or victim mentality, though. I don't think that saying you were a victim of something makes that what, you know, your mindset. I don't victim blame. I abhor it. It's something I have been gaslit about and over. I'm still being gaslit by my own parents. I'm somebody that wanted to learn what a narcissist was, wanted to learn what the problem with these people in my family really was, wanted to learn why people were behaving the way they were behaving, and I knew I had to learn that stuff on my own because I was so traumatized for so long that I couldn't complete a degree even if I wanted to. And I tried going back to community college like 4 times. With varying degrees of success and satisfaction, ultimately realizing I don't want to pay for this, ultimately realizing that I don't think I can work a normal job, ultimately realizing that there's something going on with me that I don't think anybody's going to be willing to accept in a normal working situation. You know, that I was on the decline. I had been injured gravely and didn't understand it entirely until I did. And around the same time, I became a savant who suddenly started drawing pictures with my fingertips using a touchpad on a laptop. I use this now on my desktop, which is just a mouse pad with 2 keys. You know, I've got a left and a right key, but this is what I do, folks. It's insane what my brain can do. But in an online app at Mr. Doob's Harmony drawing app, there's a link on my channel in my header, if you're on desktop anyway. I literally thought, you know, maybe some art therapy of like moving my finger around randomly with this pretty algorithmic brush that he has, but it doesn't draw things for you. It just connects some lines to lines to lines to lines to lines in a mathematical way. And I thought, you know, one day sitting in bed, leaning against the wall, like, if I just swirl my finger around and don't care what I'm drawing actually, and just push this button with my other finger so that I'm drawing things I don't really plan or know or give a crap about, that would be very relaxing. And whoa, was I right. It's just that I wound up drawing something that arguably no human could have drawn without understanding what they were drawing, and by accident like that, without thinking or planning or knowing that I was keeping an entire illustration in a 90-degree rotation, a sideways perspective that, because it's a line, it's a style of line drawing, and this is in vision science, but because it's this particular style of line drawing, you cannot understand the objects it contains, the objects represented in the drawing, in the illustration. You can't see what they are if you're looking at it, like the way it appeared on the screen as I drew it. I thought I was just drawing something relaxing and abstract that had no meaning, and I didn't have to think about it, and that's why I did it. And I fooled myself into being a genius, folks, and that's a true story. Scientists literally have no reason to believe, based on any of their books or studies or prior cases of people with dementia or autism or brain injuries that get savant syndrome or Parkinson's disease or whatever. They have no body they have ever seen physiologically capable of performing the art that I did by sheer, is it genius or is it an accident or is it luck? What is it? And then I did it again and again and again and again. And then I realized, okay, this is obviously something that isn't a fluke. It's not just the sort of one-off thing, you know, and it's not a thing that I should take lightly, but I didn't really know how to understand it. And then I realized, well, guess what, folks? The only way to understand it doesn't exist. And it's not just this book. It's not. This is a book that has been taught for decades at MIT, and I broke it. They teach it today. If you watch the human brain videos, even Nancy uses this book. She's limited in how much she uses it, but she even uses this book. And the entire first part of it, which consists of the introduction, the background, and the philosophy, and the approach, it'll get you up to part 2, where chapter 2 begins, before I stop breaking it. I broke the first, let's see if it's really, it's not really 38 pages. No, I broke the first 35 pages of the book on the subject of cognitive vision. This book is the marriage of cognitive and computational vision, and that's why they like it so much. And I hate to be the one, but David Marr, who is this icon of this field, is wrong. He's wrong in several paragraphs, several things that he says in the first 30-some pages of this book. Also, I'm a really good example of cognitive computational power involving vision in the brain. And so not only the fact that I think I can write the philosophy in that part of the book better, which I know I can, but the fact that I would be a beautiful example to have in that book, and which I think would spark a lot of interest in the interdisciplinary approach of art and neuroscience, which is extremely challenging. You know, I'm going to wind up at MIT, y'all, and I'm going to be a contributor to their coursework in several courses, not just one, and across a few different departments, which I broke. I've broken people, not just the book. I've broken people and their theoretical trajectories. I've broken whole courses. I've broken departments. I've broken institutes and what they thought they would ever see a person achieve with computed vision in the brain, with computational vision, as well as this cognitive vision crossover. Okay? Because, you know, like I said at the beginning of this video, trying to figure out how we can make machines do things versus how people actually do them is extremely fascinating these days. And not only did we not think a person could do what I do, we don't really have machines that can do it as well as I do it. Vision has been one of those challenges for computer scientists. We are much better at it. We've known that. Humans are much better at vision, but it also is task specific. And yeah, advances get made, right? Advances get made that even the scientists don't know how to explain necessarily in computer vision. But this is not the sort of thing that a computer merely winds up learning by accident, although maybe it is. It's just maybe so extraordinarily unlikely or improbable. The way I'm approaching it, though, is with my own theoretical model that I obviously think deserves its own equation as I demonstrate it. I think that I am actually demonstrating a model, not a model that can be reproduced across other people, but a model that wound up being a fluke of genius, kind of luck, savant syndrome, unlearned skill that repeats itself whether I know how to intellectually or not, whether they believe it's possible or not. And it scares me. Frankly, it scares me. It scares me because that's asking a lot. You know, it's asking a lot. It's also giving a lot. It's also extraordinarily important and rare. Maybe exceedingly the rarest cognitive demonstration on Earth. That's not a joke, you guys. It's not a joke. Y'all folks, people, everybody. So, that's me. That's what I do. And I love keeping up my skills and learning everything, every kind of way that makes me better at what I do in modeling myself. Or it's really not myself. I don't consider it myself. It's distinct from my prefrontal cortex, from my mind, from who I am, yet it informs me now so much that I want to shape who I am around it. And it's so profound and incredible that why wouldn't I want to do that? And why wouldn't I want to use the contribution it signifies to make something of myself, you know? Jordan can suck it. Boom, there it is. Jordan can effing suck it, because this is more important than anything he has ever done or said, no matter how many millions of people buy into his garbage, his nonsense, his crap, his bad math, his bad theory, his unwillingness to continue developing his theories. You know, he just wanted to write a big book and then be done and teach it and coast. And that's what he's done. That's a bad scientist. It's a red flag. He's a bad scientist. That's the truth. I'm not being harsh. I'm being honest. He's a bad scientist, and scientists today consider that kind of career trajectory for someone aiming to be a scientist as a bad one. It's bad. Like, no, you're not a scientist, Jordan. You did some science before. Okay? You're not a scientist when it comes to anything to do with most of the things that you talk about. And anytime he recites or regurgitates the same old crap, it's never really further than before. Like, he moves at a snail's pace because he doesn't read enough, because he can't bring himself to appreciate other people's work enough. He doesn't really love it. He's not really in love with it or passionate about it like he is the Bible and Russian literature and Russian autobiographical and memoir. You know, I don't know what else to tell you about it, but like he thinks just doing something is enough. It's not. If you want to just do something, you will be mediocre. You will be. You could get really good at something you actually enjoy and are just sort of maybe inclined to be good at. That doesn't mean you'll be passionate. Like, I used to be really good at bussing tables. And it was a very physically demanding job. And I loved that. I loved having a physical job. I loved having a physically challenging job. I had to go up and down this ridiculous staircase with a tray full of beer pints, glass beer pints, you know, and of course it's like, how much can we load on this tray and go down this very long, very steep staircase that's carpeted and slippery, you know, how fast can we do that stuff? I loved it. I loved it. And we, you know, I loved, but okay, let me explain it this way. But what I loved about it, I didn't understand at the time. And now looking back on it, it's because I was so efficient visually at seeing when and how I could calculate people getting up and leaving, people being done, people putting empty things aside. And it was like miraculous to me. And I'm not just saying it, like in this restaurant I worked at, where I had this very good flow, people thought that I was the best they had ever seen. And I'm not just saying that. I was extraordinarily hardworking and good at this job. This was my second job, not my first job. And I loved being physically active, using very basic visual skills like that, not having to socialize with people, which I didn't realize then, but I liked not having to socialize with people. And I liked helping people. So like I liked and was still interested in working with people and providing something and then getting rewarded for it. And I was rewarded handsomely. I was, you know, in the late mid 90s making, oh God, well, it was easily $15 an hour then, which was 3 times the minimum wage. And that is amazing. Even for that kind of job with a tip out, it was amazing. I have never since then made as much in a restaurant. Even today, I would struggle making as much money as I made then. But I was young, I was in great shape, I had a lot of energy, I was naive enough to think in the short term and not see it as the long-term screw that capitalism will turn. I was able to just be excited for it and wanted to do it. And I mean, I would show up. I didn't always want to go to work, you know. Every time I went, it wasn't always like, oh, you know, I'm unbelievably stupidly optimistic, but like when it was time to play the game, it was time to play the game. And I was very competitive about it. I was very good at what I did. And I lost that. I lost that. I'm not going to talk about what happened, but I lost that. And I lost that for so long. And now I have a physical disability. I don't necessarily seem like I do, but I have an extreme pain disorder caused by pain created in my brain from ongoing trauma and stress. But now I have a visual skill that is mind-blowing, groundbreaking, earth-shattering, bubble-bursting, theory-destroying, theory-creating, science propelling, you know, all these things I could say. And it's so exciting to me. And like, yet, yeah, there's parts of me that are insecure. You know, there's parts of me that I don't want to seem bitter, but there's parts of me that are pretty rightfully pissed off at how people treat me, especially in the scientific community, when I try to convey to them that I understand what I'm saying, especially, you know, and even the fact that like my emails have been ignored by doctors. That's what really hurts for years, you know, years ago. Just, I can't write to someone like Simon Baron Cohen, no matter what I've done, and expect him to think he hasn't already gained his crowning achievement of his career. Like for him to think that he should even take the time. It's like, well, hold on, Simon. Actually, I'm contributing something great. And if you were to involve yourself, it would be great for you. And so if you want to treat me like I'm some second class genius because I'm not what you expect, or you just don't think you can believe it and you don't want to take the chance at finding out more, if you're really genuinely uncurious and unconcerned with other people, that it doesn't even, you know, you don't even, if it doesn't even pique your interest to find out if it's real, then go F yourself. Like, what do you expect? Eventually, this will eclipse you, whether you or I like it or not. It will, if I keep working at what I do and keep producing drawings and now produce, you know, footage and documentary footage, especially of my drawings, and maybe get funded for a documentary about myself. I recently won a grant for a photography project, a film 35 millimeter photography project of my local Food Not Bombs, which I participate in weekly, actually multiple days a week, because I do my own contributions to that as well. And I learned, it gave me a lot of confidence actually in grant seeking, you know, winning. It was a fairly large organization, excuse me, that I won this grant from. And it was for a substantial amount of money to do a film of a 35 millimeter photography project. I won $1,000 to shoot rolls of film on my camera of portraits of my friends and our mutual aid work. I mean, it's like incredible. You know, I feel so much better about my art and science contributions now that I have the other thing under my belt. You know, I do think that I'm not trying to be some kind of left woke perfectionist or anything. This is just who I am. And I've been this person for a while, you know, and to the chagrin of people like Jordan, who are not going to get away with ignoring my contribution and everything else I say about them forever. You know, Jordan can go away. He can F off. He can retire into the sunset and ignore everything everybody says, and then show up every once in a while and talk to one of his friends who's never going to be like, oh, yeah, you know, but there was actually that savant, Jordan, you know, 10 years down the road. Oh, yeah, you know, Jordan, there was that genius, and she's really a genius. And she didn't do it your way at all. She did precisely the opposite of everything you said a genius has to be and has to do to be a genius. And that's the truth. And she broke the freaking mold and did something they didn't even think was humanly possible. Now what, Jordan? Now what? It wasn't a skill that she developed over time like an athlete. That's not what savants do. They automatically harbor a mastery for something the very first time they ever do it. It's like, imagine the basketball example. Imagine all you ever thought was you needed to sink baskets and you never miss from the very first attempt. Let's say the very first time you ever saw a basketball game. Let's say afterwards you were able to go out onto the court and hold a ball for the first time and shoot for the very first time and you sank it the very first time. And from then on, no matter where you were reasonably on a court space, let's say you shot with like something into the 90s of a percentage, you would be considered a savant of basketball. But sports are usually played, if they're played by a genius, by prodigies. I don't want to talk about that really, but anyway, that's an example of how it works. Playing the piano, the very first time you hear it, if the first time you ever heard a piano concerto, if you were able to then sit at a piano that evening and repeat that concerto back without reading music, without ever having read music, without ever having played a piano chord in your life, you would be a savant. And this is the kind of stuff that we do. My example of it, we never know what they're going to come up with necessarily, but they have some repetitive skills like calendar counting, which is telling you the day of the week of any date. March 11th, 1971. What day of the week was that? A savant who can calendar count will just tell you the day of the week. They'll just get it. Their brain will do the calculation for them and they'll just know. And right. So the difference between that is I'm not expressing anything verbally when I do this art with my fingers. And I'm arguing that verbally, I'm telling myself the opposite, actually. So this is, this is something very complex that if I work out verbally later, after the fact, a posteriori, becomes incredibly exciting, something I actually have to work at, have to put effort into, have to be competitive at, have to get my foot in the door, have to model, have to have published as a paper, have to get a grant for a documentary to show people about it, have to get MIT to give me a job and or get the government to fund my lab or whoever. I mean, the sky's the freaking limit, right? It would really help this channel and the future of cognitive science if you subscribe. Good luck in everything that you do, and I hope that once you realize abstraction is not scary and it's not hard and it should not be intimidating, and that men like Jordan are using it to intimidate people like you and me even, you don't have to fall for it, and that you can stand up and say that's wrong, and there is a better science out there, and science shouldn't treat people like crap the way Jordan does, okay? That's what I want people to understand. And if you're like me and you are extremely experienced and injured and traumatized and you don't know where your life should begin and you don't have a lot of support like I didn't until I moved in with my friend that I live with now, who's making all of this possible for science and myself and the rest of the world, basically, and the future of knowledge of the human cognitive feats. If you're out there and you're having a hard time living on the street, doing sex work that you really aren't happy with, that you're doing to survive, if you're in a terrible situation or circumstances at home, if your family is gaslighting you into oblivion, if you really feel like nobody loves you, I was that person. I was that person for decades. And it broke me, okay? And more, there's more obviously to it, like fact-wise, but it broke me. And I want you to understand that I don't want you to break in order for you to find out that it's okay to ask for help or to tell people that you really need help and to face the shame and the humiliation of being that person socially that needs help. So I don't really have any good resources for you. I personally don't think there really are many, But I do think the best thing you could probably do for yourself is figure out how to get a primary care physician and go see your doctor regularly and try to tell your doctor as many things as you can about the way you feel, your health, your mental health, etc., your lifestyle, your family. And mental health resources are scant. I realize they can be a waste of money, they can be a waste of time, they can be a waste of energy, of effort. And so I don't know how to help you there. I really don't. I don't necessarily think BetterHelp is a good app for people. I think finding free resources could be better. But I also know that if you have complex issues like I did, and you're a woman and or a trans person or non-binary person, that yeah, you're really gonna have a tough time. You're really gonna have a tough time. Um, Finding people who will even try to understand you and not misdiagnose you. I tell people, like, I've seen so many doctors as far as psychiatrists and people who've diagnosed me who aren't even psychiatrists, but people who've diagnosed me with mental disorders. And I've never been diagnosed with the same things twice. So what does that mean? It doesn't mean that I actually meet the criteria for all of those things. It means that there's a problem in the industry. It means there's a problem with the practitioners and with the way that they ascertain how they should be diagnosing people. And if you learn probability, you will learn to be formidable against all of these people who are going to tell you things that you maybe shouldn't believe. The way I look at medicine and psychiatry and anything having to do with me these days is if it doesn't have a lab test, and the doctor isn't humbling themselves to me, the patient, to try to get more information and be curious about me, then they can F themselves. And I will not probably take what they say seriously or believe it. And that's a much better way to be, even though it's going to seem insane. And when you start looking at society through your experience and you realize how many people out there are on drugs because they're misdiagnosed and somebody just said, here, let's try this. It's baffling. It's madness. It's maddening. It's enough to drive you over the edge. I realize it. I realize people who can generalize may be the people having the worst existential crises. Jordan has even said something like that. But it's not the kind of thing he'll like caringly come back to and make himself about. He makes himself about himself too much, and he can't stop until he's stopped, or he is compelled to stop. And he doesn't want to be made fun of, or he'll act like he's gonna cry and that he's, pathetic and weak and women are just the most evil and cruel, which they're not. He really is just maybe the most overrated, overtrusted, underwhelming person on YouTube who has credentials and who taught in college. And the way that the way those guys will shun a Robin DiAngelo and embrace a Jordan Peterson, man, male supremacy. I really am gonna leave y'all this time. Like I said, liking and subscribing to this channel will help me so much. It will help me. And when I say help me, I don't mean it will only help me. I mean it will do the things that I need to do for me. And that means doing things that actually impact the rest of society, the rest of the world, and a new understanding of the human brain as a scientist. And it will help me get to bigger, better projects, papers. It will help me come back and teach you more. It will help me do all these things that are so important. Um, anyway, I am gonna let it go. Have a good one. Thank you.